Hello, welcome. Let's try to solve another Leetcode problem. 2528. Maximize the minimum powered city. So first let's try to understand the problem. So we are giving a stations. So this stations array means for each of the station I represents the number of power stations in the ith city. So the stations array just means the number of power stations. So for this example, let's just use maybe for this one. So we have an array of stations. It's going to be 1, 2, 4, 5, and 0. And we are also having a radius and this k. So this r is just a radius. This means in which radius, so for the power station can supply power to this city. So for example, this is my city 0, and each of the power stations have a radius. So for example, this 2 have a radius of 1 because these are equal to 1. It means it can go from here to here. Yeah. Basically for here I have another 2, right? Yeah. And let's just check another one. And for this one, of course, it have a radius of 1. It means in this areas, maybe, yeah, let me make a better drawing. So yeah. So for example, for this one, it have a radius of 1. It means basically in these areas I can supply a power of 1. So in these areas. And for the next one, so for example, this 4, I have a radius of 1 and I can supply 4. And another one for this 5, I can let me make it the drawing here. I can supply 5. Yeah. And for the last one, it is a 0, so it is okay. But that means just make a drawing. It is a 0. So after that, we can calculate what is the currently maximum power do I have in each of the city. So up to here, that is go out of the boundary, it is okay. We will not count it because there's no cities. And for this one, this is 1 plus 2. So at index 0, it's gonna have 3 powers. Yeah. And at index 1 here, so this is the index 1. So we're gonna have 2 plus 1 and plus another 4. So it's gonna have 7 stations. And what about here? So this is 4 plus 5 and plus 2. It's gonna be 11 powers. And what about here? So for here it is 4 plus 5. So it is 9 powers. So what about the last one? This is 5 and 0. So 5 plus 0, it is 5. Yeah. Now we get our updated array. So this is the maximum power do I have at each of the city. It is 3, 7, 11, 9, and 5. But I have an actual power stations of 2. It means I can put those 2 power stations into any of the places. Maybe I want to put the 2 stations at here. So it means if I put it here, basically it means in these areas, basically I can add another 2. It means this 3 gonna be updated to 5, and this 7 gonna be updated to 9. So up to now, the minimum power in this array gonna be 5, and this is the maximized the minimum value, so it's gonna be 5. So this is why we're gonna return a 5. If we understand about this, now basically we can find some way to solve it. Yeah, because what is the maximum possible minimum powers of a city? So for our calculation, it is 5. But how can we check that it should be 5? It's going to be really difficult. Yeah, maybe we're going to guess one by one, but how many of them? Definitely, it is not like that. We cannot use a brute force. So we have to guess. Maybe we're going to check if this kind of a property has some monotonic increasing or not. Yeah, it means, so for example, for the output, I want to guess a number. Maybe I guess a number 100, maybe. Yeah, so if 100 is okay. Yeah, so this output is just the maximum possible minimum power stations. If this 100 is not okay, yeah, maybe I want to guess a smaller value, maybe 50. I want to guess a value 50. If I have actual 50 stations, can I keep if I have actual 2 stations, can I keep the minimum to be 50? No, we cannot. As for this example, it is a maximum, it can only be 5. It means 50 is too big. Maybe I'm gonna guess another value according to the binary search. If maybe I'm gonna guess a value 4. If I guess a value 4, so because this k equals to 2, can I have a value of 4? Yes, I can. So maybe I would want to guess a bigger value. Yeah, because if 4 is possible, maybe a bigger value 5 if it is possible or not. So I will guess this 5. So if it is 5 plus the actual value 2, if I put it at this position, basically I meet the condition. So the minimum value is going to be 5. It means I meet the condition. So finally, I'm going to return this 5. Yeah. So this is the global idea. So we're going to use a binary search to just guess a number if it is too big. So we're going to guess a smaller number if it is too small, and we're going to guess a bigger number if it meets the conditions exactly if it is 5. So we're going to return this 5. Yeah. Now the problem becomes how can we calculate each of the requirements? So for example, the first requirement is what is the maximum power at each of the stations. So we can calculate it directly by using the prefix sum. Yeah, because basically it is a radius, and we want to plus all those values around these areas. Yeah. So for example, for this for the first station, what is the maximum power? I can use prefix sum. Yeah, because at this area, what is the total stations up to here minus the total stations up to here? Basically, I can use the prefix sum to check the maximum power at each of the stations. If I have the maximum power at each of the stations, so now I have an array. Maybe let me check it. Maybe this is an example. Just maybe we have 3 stations. So this just means the maximum power. So it's gonna be the maximum power at each of the stations. Now, if I have this maximum power, I can use it for the next step. So the next step, we're gonna use a difference array. Yeah, because basically we want to add some stations. So while we add the stations, maybe we add one station at some place, add another station at some other places. Yeah, but if we add a station, so for example, if we add it here, so the radius is gonna be 1. So it is a range actually. Yeah, we cannot add it one by one by using the brute force. We have to use some clever way, so it's going to be the difference array. So for example, we want to add in these areas. We want to add just one station. So what it's going to be? So from here, it's going to be a plus equal to 1 because it is one place. Maybe k station, it doesn't matter. But at here, after that, it's going to be minus 1. So in this way, we can check what is the stations at each of the places. Yeah. But we cannot add it one by one from the beginning. We have to add it online. I mean, while we are calculating it, we have to add it one by one, and in this way we can check what is So according to here, basically we can check the total stations. What is the total stations do we have? And then according to this k, we can also check how many stations do we need. Yeah. So if we can prepare some actual stations, some actual value. So if this actual value, this actual stations just means how many actual stations do we need. If it is more than k, this k equal to 2, definitely it means it's not possible. We're gonna return a false. Yeah. So otherwise, for the actual stations, if it is always less than and equal to 2, basically we can return a true. So the difficult part is how can we update the difference array online. We will not update from the beginning, but we will update for each of the calculation. And this is just to separate the difference array. So for example, if this is a range, this is another range, definitely we're gonna use we're gonna set the difference array, like here plus 1 and go outside minus 1, here plus 1, or go outside minus 1, and then we're gonna use the prefix sum. But for this problem, we're gonna just separate it to calculating it online. We will not calculate all together. We just separate for each one of them. And it's the same idea. For example, for this one, actually at this place, we can also calculate what is the number of what is the power at this place, or what is the power at this place. We just need to check if it is less than and equal to our guess. So for example, our guess is 5, maybe at this place we checked all the values, it is 4, so it is okay, and this is 5, it is okay. But if this is 6, it means we need one more extra power, so it means we're gonna consume one of the power stations, and we're gonna set it we're gonna set this power stations at this place. So if we set it at this place, basically we need to update the difference array. Now I want to try to start it by using the binary search first. So I think this is gonna be easy to understand. Basically it is a template. So I'm gonna use 0, 10 to the power of 20, and result gonna be 0. So the right side, the maximum value gonna be 10 to the power of 20, because here the distance I is 10 to the power of 5. So the radius may be 10 to the power of 5. So it is 10 to the power of 5 times another 10 to the power of 5. It is 10 to the power of 10. And we also have k actual distance. Maybe we're gonna put the k actual distance at the same place. It's gonna be times 10 to the power of 9. So it's gonna be 10 to the power of 19. But I said 10 to the power of 20, it should be big enough. As we already have this r variable, so I'm gonna use left and right variable. So it's gonna be left and right. And now we can just finish this binary search template. So left should less than or equal to the right, and mid gonna be equal to the left plus the right, and divided by 2. So we're gonna prepare another function check. So if check this made, so I'm gonna prepare this result gonna be the made, and here it means it is possible. So if it is possible, as I was calculating the maximum minimized value, so I would to set the left to be made plus 1, because I want to find a bigger value. So if it is not possible, so I'm gonna try a smaller value. So it's gonna be made minus 1 for the right. Finally, I want to return this result. Now I want to finish this check function, and inside I want to give a threshold. Now let me give a path first. First of all, I want to check the powers at each of the stations according to this stations array. So we have this stations array. I'm going to prepare variable n, going to be length of the stations. Now I want to check the prefix sum of the stations. So the list accumulate. This is just used for calculating the maximum, the powers at each of the stations. So accumulate the stations, and the initial going to be 0. Now I want to check the stations. So for I in range n, so the maximum power, I'm going to use this stations array. So the stations I going to be equal to the prefix sum of I plus r. It's going to be, because it may go out of the boundary, so we're going to check the minimum of I plus r plus 1, because we have a padding 0, so we're going to plus another 1, and the boundary is going to be n, and minus the prefix sum of the maximum of I minus R. We need 2 plus 1, but this is for the minus value, so we need 2 plus 1 and minus 1, so it's going to be maximum of I minus R with 0. Yeah, so this is going to be the maximum power at each of the city. So the I is the position of the city. Now we can prepare this check function. We can prepare a total. This total, it means just the prefix sum. This total just means what is the accumulated. This is it. The total is just the accumulated difference array. It means my current power at this this city. Yeah. So the total, and I'm gonna prepare another variable, actual stations. Yeah, this actual distance just means the actual distance I will need to get my threshold value. Yeah, to get this threshold value. So from the beginning, it's going to be 0. Now I want to prepare a difference array, and it's going to be f0 times n plus 1, length of the distance plus 1. Yeah, because for differences we always want to prepare an actual value, and for this one, yeah, because we're gonna use the start and add plus 1, so this is why we're gonna prepare a n plus 1. Now we want to enumerate all the values. So for I and power, enumerate the distance. So I want to check the first of all I want to check the prefix sum, so the total gonna plus equal to this fi. Now I want to use another variable. I want to use maybe this station to represent how many stations do I have, how many powers do I need for the current position. Yeah, maybe I'm gonna use station power. Yeah, maybe station num. How many stations do I need at the current position? So at this position, so it's gonna be the threshold minus the current power at this city, and minus the value calculated at difference array, because from the beginning this total gonna be 0, but after some calculation I will add some actual stations from this k, so basically I would to minus this total. Yeah, so this is the station number. Now I want to check this station number. So if this is station number is more than k, so yeah, if it is more than k, it is not more than k, and this number should be, if it is more than 0, it means I need some actual stations. I need some actual power stations. Yeah. So if this station number is more than 0, so I can get it to the actual stations. Yeah, I can calculate the actual stations. Basically, it's gonna plus equal to this station number do I need. Yeah. But if this actual distance is more than k, basically it means it's not possible. I'm gonna return a false. Otherwise, I'm gonna update the difference array, because currently I have some values and I want to update it in difference array. And the difference array, so the total gonna be just like the start position, the beginning. The total would plus equal to the station number, and I would to update it at the add position. So it's gonna be I. If I have to check if it is inside the boundary or not. So if I plus 2 times r plus 1, if this is less than n, I would to update it. So fi plus 2 times r plus 1 should minus equal to the station number, station num. Yeah, and finally I want to return a true. Yeah, if it is not false. Yeah, otherwise I'm gonna return a true. If at any of the calculations, at any of the positions, if this actual station is more than this k, definitely I'm gonna return false. Otherwise, I will still updating. If there's some k, I'm gonna use it. Now I want to run it to have a check. So the accumulate. Let me update this. Check this accumulate. Now it seems it works. Yeah. Now let me just submit it to check. Yeah, as you can see it works and it's pretty fast. Now let's analyze about the time complexity. So for the time complexity, basically this is a big value, like 10 to the power of 20. But for the log of 10 to the power of 20, maybe it is just 50. Yeah, maybe this is just 50. So 50 times the check. So inside of the check function, basically it is on. It is 10 to the power of 5. So it means 50 times 10 to the power of 5, 5 times 10 to the power of 6. Normally it should work. I think the difficult part may be from the beginning, because it is a radius, we can calculate for each of the city, like 0, 1, 2, 3, and 4. We can calculate the maximum power. Yeah, maybe this is 4, 5, 3, 2, 2. We can calculate the maximum power. This is what we used for the prefix sum. After prefix sum, according to the distance, it definitely is going to be a radius. We can calculate the maximum power at each of the city. And the second step is that this is the minimize maximize problem. We're going to use a binary search to guess a value. If we were to guess a value, maybe for example for the first example we're going to guess a value of 5. Yeah, but we are giving a variable k. This k is the number of actual power stations do we have. So we need an actual power station variable. Just we need this actual stations variable to check how many actual stations do we need. Yeah, if it is more than k, and we're gonna return a false. Yeah, and how can we accumulate these actual stations? We just need to check. So this station num is the current station number do we have if we want to meet the threshold. Yeah, because the threshold, for example, it is 5. So 5 minus power. So for example, this power is 3. And this total is just for the difference array. Currently it is 0. So 5 minus 3 minus 0, it is 2. So our station number is gonna be 2. It is more than 0, and it actual gonna be equal to 2. So this actual, if it is more than k, but our k is 3. So for this example, yeah, for the first example, maybe k equal to 2. But 2, if this 2 is more than 2, we're gonna return false. So 2 is not more than 2, so it is okay. But we want to update this total value. This total and here, this is just updating of the difference array because we want to use this actual value. How can we update it? So this is gonna be the start position. From here, we're gonna plus equal to 2, and this is gonna be the add position. So the add plus 1, it is here. It's gonna be minus 2. Yeah. So this is for the difference array. But how can we check the total value? Total value is just the real value after accumulated sum. So this is just the total plus fi, and we just according to this, we're gonna get the total value. So total value, this is just for difference array. But what is the actual station number do we need? It is the threshold minus the power, it is inside the array, and minus another value that is from the difference array. So that now we get the how many stations do we need. And if it is more than 0, it means we need more stations, and we're gonna update it to the actual stations. Yeah, so this is gonna be the total operation of the problem. Thank you for watching. See you next time.